Problem 3. Given that the distance between the points 3, 4 and 8, 16 is the same as the distance between the other 2 points with the variable, find the sum of all possible values of A. All right, so we're talking about the distances. It means we will need the distance formula. Let's write it in general. Let's say we have 2 points, x1, y1, and the second point, x2, y2. What's the formula for the distance between them?
So you'd need, distance is basically also Pythagorean theorem, because it's kind of like a triangle with legs, and the distance is the hypotenuse.
Yeah, this is one point. Let's assume it doesn't really matter, but let's assume that the second point is this direction. And then the distance formula is this hypotenuse. And we can figure out the legs of this triangle. What will be this vertical leg, Ivan?
It's going to be y2 minus y1.
In our application, if you want it to be in general, we can put absolute value lines. And when we square for the Pythagorean theorem, they won't matter. In my orientation, y2 is higher, so I can keep it like this. And the horizontal leg
is going to be the same thing, but with x's. So x2 minus x1.
So just be aware that it's actually absolute value if we don't know the relation of the points to each other. Okay, so to find the distance, we will do Pythagorean theorem, and let's write the formula.
So the formula will be, we can start with x's, x squared minus x2 minus x1 squared
Plus, the first leg.
Plus y2 minus y1 squared.
All right. And notice in the Pythagorean theorem, this formula would have been like this, but usually you see it in the textbooks with the square root. And for our problem, do we want it with the square root or not? What do you think will be easier for us, Ivan?
It's going to be easier for us to...
Well, I will pick. Let's do it squared both sides, because we don't really need to introduce square roots because we are solving for the variable. And here the distance formula will be a number, but for these 2 points, we will have a variable squared. So we'll just use the square of the distance formula. Yeah. And since distances are equal, the squares of the distances are also equal. Now we will use the numbers from the problem. So first, let's compute the square of the distance between these 2 points.
So the square of the distance, we're going to take first, let's say 8, and subtract 3 to get our horizontal, which is going to be 5 squared plus 16 minus 4 squared, which is going to be 12 squared.
So 5 squared plus 12 squared. And that's a familiar Pythagorean triple. It actually will be 13 squared. We can also compute 25 plus 144 is 169. 13 squared, 169. That was for the first 2 points. Let's write an expression for the second 2 points, these ones.
So instead of d squared, since we already know that the distance is going to be the same, we can have 13 squared.
Well, it's the same thing, right? Okay. Oh, you mean instead of d squared, we will write 13 squared. Yes, I agree. We'll write 169.
And then since we do not know some of the digits, but we do know 5 and 12, we can input 5 as y1.
All right, and 12 as x2, because that's the second point. Okay, give me the expressions.
So it's going to be 12 minus x1 squared plus y2
And
minus...
x1 is actually a, right? I will write a because this is my first x value.
Yep. X minus a, and also a minus 5.
And a minus 5. So 12 for the second x value, a for the first x value, their difference squared, then a for the second y value, and 5 for the first one. Sometimes when we do slopes and stuff, we have to keep track of the order. Here, because we are squaring, the order is not really important. All right, this looks like a quadratic equation. Let's distribute the parentheses on the right side.
Yeah, we'd have 169 is equal to 144 minus 24a plus a
squared. We're using the formula a minus b squared equals a squared minus 2ab plus b squared. If you have forgotten it, it's totally fine to just do the distributive property, the FOIL, and write the 4 elements and combine like terms. Okay, so for the second parenthesis,
we'll have a squared minus 10a.
Yes.
Plus 25, or 5 squared.
I didn't write 169. I'll write it here. Now let's combine like terms and cancel what we can cancel.
Yeah, we can combine both a squared. We'll have 2a squared.
Yes.
Yeah. We can also combine the singular a's, so we'll get negative 34a.
Let's look at the numbers. We have this.
And then we can just, the numbers will actually just cancel out because we'll have 144 plus 25. So that's 169 on each side. Cancel.
So the numbers cancel.
And we're left with 2a squared minus 34a equals 0.
2a squared minus 34a equals to 0. Okay, how do we solve this equation?
We can first factor out 2.
Let's factor out 2a because we noticed that this is a squared, this is a, so we will factor out 2a in one step.
We'll have 2a parentheses a minus 17 equals 0. Yep.
So we have 2 terms and the result is 0. So we will have 2 solutions.
Yeah. So if 2a is equal to 0, then a must equal to 0. So one solution is a equals to 0. And the other is if inside the parentheses, we'll get a 0. So a equals 17 is the second solution.
And the problem asks to find the sum of all possible values of a. So our answer will be 0
equals 17.
Okay, so distance formula here, which we showed, is the Pythagorean theorem.